And in this video we'll be studying the concept of branches and how to merge them. What is a branch in Git? In reality, in order to understand what branching is, we need to figure out how Git stores data. Git is based on a graph, which means that Git itself is one big graph that contains a very large number of nodes with some kind of links between them. Each commit references the previous one. If we open Git bash and call the git key from there, then we'll be able to confirm that the commit history is mostly linear. Here we have an initial commit, from it comes the next one, and so on. Each commit has a mandatory field, which is parent, the father commit. And this way we can keep moving up a level higher and higher, and we can basically go back to the original, the very first commit that was created in our repository. The history is linear, which means that every change references the previous version. But this is not all that you can do in Git. Git also allows us to create branches, like a tree. A tree has a trunk which grows upwards, and it has branches which can grow upwards and sideways, and so on. The only difference is that in a tree, branches cannot grow back into the trunk, but in Git they can. How does that work? When I'm working on a project, when we are writing code, we as a rule have a certain set of features. The code is written with the purpose of creating some functionality. We have a feature, some functional element, or a set of features. This basically is our product. Any product can be subjected to decomposition, be deconstructed into a set of some functional characteristics. That's like a music player. It has a capability to play music tracks, create playlists, perform playback, adjust the volume, etc. Git is very convenient in a way that there are multiple branches that allow you to track the life cycle of a specific feature. It's not a required condition of using Git, but the capability is there. How does it work? To put it in the more simple terms, then a branch is a situation when several commits have a single shared ancestor. In the case that we can see on the slide right here, we have a commits A, B, C, and D. They follow one another linearly, but from the commit A there is a small commit F branching out, and it has its own structure. It can move forward independently from the master branch. The default main branch in Git is called the master. In addition to it, we can create more branches. Here is an example. Let's say this dark blue large feature. A commit has popped off from commit C, the commit E was created and continues moving forward. These commits, the last two out of the large feature, they won't be visible to someone working in the master, but they can be added back to the master. The operation of adding stuff back into the parent branch, these here are what we call branches. When we create a branch, that is called branching, meaning we have branched off from somewhere. The opposite operation, when we are adding a branch to the upstream, returning it to the source branch, is called a merge. What does a merge look like, and what types of merges are there? This is merge that we could imagine is called fast forward merge. Why is it called that? Fast forwarding means bringing something forward. How does this work? Imagine that we have a master branch that has 3 commits A, B, and C, and from the commit C we branched out into 3 more commits, meaning there is now a feature branch that starts with commit D, E, F, and so on. Git has the concept called head, which is the main commit. Imagine a train that consists of a number of cars. Here the head is this steam engine that's pulling them ahead, the leading commit. When we create a new commit in Git, the head pointer is moved to it. When I'm located in the commit B and C doesn't exist yet, the head is placed on B. When I create a commit C, the last commit is, as a rule, the leading one, and the feature also has its own head. It means there is a head of the feature, that would be commit F, and there is a head of the master, that's commit C. Commit D is descendant of commit C, but the master branch of commit D doesn't exist, it exists only in the feature branch. In order to return this whole structure D, E, F, to bring these commits back into the master, roughly speaking, to copy them into the master, we can perform a little trick. We can simply move head from the master and onto commit F. That way we define that the head train car in the master is now not C but F. And this is now as a fast-forward merge, when we simply rewind the pointer, meaning we put the pointer in a new spot. We use the reference commit C, and now we're referencing commit F. Let us reproduce a situation like that and see what it's going to look like in Git. The first thing we need to do is to create a branch. To create a new branch and immediately switch to it, we can use a command called git checkout. I call git checkout, specify flag B as the branch, and for the name of the branch, let's make it feature. And now I have created and switched to a new branch called feature. Let's create something new in this branch. Let's use this branch to add a second verse. Save file and commit. Okay, now let's create another commit and see how the heads will be different in the master and in the feature. Perform similar steps. Okay, all done. Let's open the file system, go to the .git directory and see what we've got in the head. The head references the feature, that means that we're currently in the feature branch. Git confirms that and shows that we're currently indeed in the feature branch. Let's see what our head is now. Refs, heads, feature. Okay, here's our current head, 5BD9. Let's call a git log in the feature and see what it returns for us. Git log is showing that the last commit is also the head of the feature branch, which is 5BD9. And this is the third verse of the song I'm writing. And now let's go to the master branch. Git checkout allows us to switch between branches. I select git checkout master and go to the master. So now in the master branch. What's git log going to tell me now? In the master, the head is commit E26. And now we have a different history, meaning the history of the master and the feature are different. If we want to synchronize them, if we want to make the things I created in the feature branch and load them into the master, then I need to perform a merge. How do I do that? I go to the branch which I want to add my features into. In this case, it's master. From the master, I run git merge feature. And we can see that we have a text appear right here saying fast forward. So the rewind happened. Let's check the git log. Here's my third verse and my commit 5BD. If we'll scroll up a bit, we can see that before the head merge, there was a commit E26. This was the revert of the revert. Returning to the log after the fast forward merge, we can see that these two commits appeared, and now the head in the master is right here. And that's how the fast forward merge works. Additionally, in Git there is a non-fast forward merge, which is a merge that is non-fast forward, which are all the remaining ones. How does a non-fast forward merge work? It does something similar, but it creates an additional commit. There are situations where we can't perform a rewind. Let's take a look at this scheme. We have a commit C from which we've already spawned two descendants. The master after C went on the commit D, and in the feature branch that spawned from C, F, G, and H were created. We can't simply take the head of the master and move it into the feature, because then we lose commit D, and we don't want to lose it. So the correct solution in this case would be the following. We create one more commit, which results in gathering all the changes from commits F, G, H, and D in order to avoid losing it. And that will be an ordinary non-fast-forward merge. How we do it? Let's edit one of the files, perform a commit to the master, and then a commit to the feature branch. In the master, I will edit the README file. I make some changes in the README file, called the git GUI, and add, let's call it the master commit. Okay. Now I go to the feature branch. Okay. And now here I will edit the lyrics. Let's close the refs. Now in the feature branch, I will delete a couple verses from the song lyrics. Go back to the git GUI. Commit. Alright. Now go back to the master branch and attempt to merge the feature in the master once again. What happens? The now familiar vtext editor pops up and offers to input the text of the resulting commit. That's this green commit, the one that appears as a result of the merge. And it also has automatically generated text, merge branch feature. I won't apply any changes to that, so I simply click colon, right quit, and the merge happens. Using the recursive strategy. Let's check in git k what it looks like visually. Usually we've got this interesting looking history. We have the master commit, meaning with add third couplet we branched off the feature. During this time we did a master commit in the master branch, and the feature branch has two couplets, so when we merged the feature into master, then we ended up in the following commit. The very last one is named according merge branch feature, and that's what happens in a non-fast forward merge.